And for those who are lurking on the outskirts, do join us. We have a really interesting presentation now from Netscout. We have the Chief Technology Officer and Principal Cable Sales Engineer for their service assurance software to talk about visibility and assurance. So I'll leave it with Vikram Saksena. Thank you.
Hello, good afternoon, everyone. Thanks for coming. You know, what Netscout does is really we focus on network data. And we call that smart data because we process network traffic and we extract intelligence from that that is used to feed a variety of applications and use cases. So what I'm going to do today is give you a brief introduction to what is smart data and what are all the use cases that we support. And then my colleague, Ryan, who works with many cable operators in the industry, is going to actually go through and talk about how smart data is put into action, how we solve real world problems today on a day-to-day basis, how we are addressing customer churn issues, how we are helping maintain high carrier-grade quality of the network. So we'll talk about Wi-Fi, we'll talk about video, we'll talk about data centers. So pretty interesting set of use cases. Feel free to ask questions at the end. We'll give you an idea about the technology as well as the use cases, and hopefully we'll leave some time at the end for questions. So with that, okay. So why is data so important today? You know, people talk about data because really what the data is driving is what we call digital transformation. Digital transformation in the industry is really critical for three things: agility, efficiency, and growth of your top-line services, which is what the industry needs. Now, there are 3 points I want to make. First of all, the competitive landscape. The competition from not only telcos, over-the-top providers, hyperscale cloud providers, and many niche-focused providers today, which we call as-a-service providers. These are all coming into the space that has been traditionally held by cable guys. And the competition is getting very high, and it's getting customers to look across a highly competitive landscape. Because of this reason, customer expectations are rising. Customers want everything to be better, faster, cheaper. They want the ability to personalize services. They want high quality experience. They want visibility and control, and they want stronger security. These are all the demands that are coming from customers on cable operators and the industry in general. So what are the operators doing in response to this? So operators are creating to a model where networks are becoming very agile. So we call this idea the notion of programmable networks, where networks can be programmed on the fly. Cloud-native architectures. This gives you tremendous agility. Everything moves to a hyperscale cloud model to give you a lot of agility. Automation is another point which the industry is heavily focused on, because you want to take out human intervention as much as possible, so changes can be done on the fly in real time. And of course, rapid service innovation, which is going to be key to how the operators monetize their services and create growth. Okay, so this is where Netscout's smart data strategy comes into play. So what we are doing with smart data, first of all, what is smart data? Smart data is the direct knowledge that we derive from wire data, which is actual network traffic. We deliver it in the form of service layer metadata, which is a highly compact form of actionable information. It is completely vendor independent, so you can monitor your network, which may have any vendor providing your switching, routing, CMTS technology. We don't care, because we are looking at the wires and we are capturing packets. It is universally available, which is a big advantage, because now you can go all the way from customer prem, where you're doing like a UCPE, to your edge cloud, to your core cloud, and in the data center. So it's very scalable from low end to high end. We call it visibility without borders because it works across domains. You can stitch together your service flows and your metadata and your KPIs across any of these domains, any cloud, public, private, hybrid, any network, which is physical, virtual, whether it's video, Wi-Fi, or what have you. Any workload, you can deploy as containers, you can deploy as virtual machines, you can deploy as dedicated software. And it can be pervasive and end-to-end. By that, I mean that you can take the technology down to a small footprint like one CPU, and you can put it at the edge of your network, or you can do multiple CPUs and higher data rate traffic in the core of the network. Our solution consists of monitoring all the IP services that are running on your network. We have also expanded the scope to include IoT, which is many devices that both cable and the wireless guys are going after. And the three areas that we focus on is service assurance, where we are making sure that the service quality, the operational quality of the network is very high so that your customers can feel good about the service they are getting. Security assurance, this is an area where we have expanded our technology through acquisitions and organic development so we can go after not just DDoS, but also very sophisticated threats that are happening in today's network. Finally, customer experience. We can monitor individual subscribers, their sessions, and the quality of experience on those sessions. So collectively, we feel our smart data strategy has the power to create many useful solutions that the operators need today. So what do we provide? So basically, there are 4 dimensions. You can look at things from an application perspective. You can look at it from a network topology perspective based on regions and access points or cell towers. You can look at it from an individual subscriber perspective. And you can look at it from a services perspective, whether it's voice, data, or video. The metadata that we provide are metrics related to services and subscribers. It includes both control plane and user plane, as well as session records that we create. And what is the value of this data? And so I summarize that in 5 points, which I call the basic attributes. It has all the contextual information. It is provided in a very timely manner, so real time, in the time that you need to make decisions. It has all the relevant data that you need. It filters out all the data that is not very useful. It's put together in a structured format, so you can put it in structured databases and make it useful for any application. And it is actionable because you can use it to drive decisions, whether they be regard to automation, or to customer experience, or to network changes. What are the challenges that we address in the network? So I will point out 3 key challenges. First of all, pervasive visibility. In today's environment where applications are getting distributed, you're deploying edge cloud, you have services running on the customer prem. In this highly distributed environment, you need pervasive visibility that can go all the way from the customer endpoint back into the core. And you need lightweight monitoring that does not consume a lot of resources. It is very high performance because you want to be able to do it with the least intrusive aspect. So flexible instrumentation across physical and hybrid worlds. Assurance and automation in real time. So this is a key challenge from operators, that you need the right metrics to be able to drive your policy servers, your orchestration platforms, your automation engines, because you want the changes to be in real time based on the right level of metrics that are being gathered from the network. When it comes to security, you don't want to be reactive. You want to be able to look at early warning detection and mitigation. You want to be able to catch these persistent threats as they are being slowly proliferated into your network before they do any real damage. So our notion is to secure new attack surfaces through, for advanced persistent threat. And the solution that we provide today is using smart data that can provide early warning indication. So what do we support in terms of use cases? So this is where the power of smart data comes to the fore, and we will talk about the use cases. But basically, solutions that we deliver, either directly ourselves or through partners and third-party applications, provides all the stakeholders in an operator to be able to use smart data in a valid way. So customer care. Data is used to reduce churn, improve net performance score. Network planning people can use this data to provide just-in-time resource management so you don't have stranded capacity in the network. Threat management for security people, not just DDoS, but advanced persistent threats. Product teams can use our data to personalize services. End customers can actually have visibility. So in services like SD-WAN, enterprise, business services, they want to look at their data in real time, and we can provide data feeds into application performance for individual customers. And finally, zero-touch automation for the operations team. This is where you can drive, through modern orchestration platforms, complete end-to-end orchestration of your network. So we create a lot of value from smart data. The power of smart data is what enables these use cases. And what we're going to talk about next is really to show you smart data in action. And I will call Ryan now to go through some key use cases today, and also in the future that we are addressing for the cable MSOs.
Thank you, Vikram. So what I thought we would do in the next 20 minutes is take you through 3 different unique use cases that I've been involved in. For those that don't know me, my name is Ryan Eccles. I've spent the last 7 years of my life helping MSOs effectively instrument and monitor the services that they're offering to their customers. So what I wanted to do is take the smart data concept and apply it to a couple different things. The first and foremost is going to be Wi-Fi, and show you how they are using some of these MSOs that are using our Netscout system, how they're applying it to what they're doing, and how they're ultimately getting to a point where they can ensure their subscribers' experience is stellar. So in terms of the challenges that we see in the Wi-Fi world, I would say Wi-Fi is no longer a best effort kind of service. It's really becoming something that needs to be as robust as the carrier wireless networks. That doesn't mean that in certain cases you're not getting a ton of phone calls. In the Wi-Fi world, you don't get a lot of problem calls, at least today. So when someone does call and report a problem, it's difficult for the operator to know where the problem is. Is it limited to a single subscriber, a group of subscribers? If someone's complaining, for example, about their inability to authenticate onto the network, same sort of challenges. Is it a systemic issue with my AAA server? Is it limited to a region, a group of subscribers? Another one that's very common is, controllers, if you're having stability issues, they could see a group of 10,000 or more access points automatically switch over to a different part of the network. That's something they need the ability to detect, to report on, so that they can understand why that happened. And last but not least is single subscriber quality complaints. So if I call up saying my YouTube or Amazon experience was terrible, they are looking to us, to Netscout, to provide them the smart data to show them that, yes, this user is or maybe wasn't having a problem. So what I'm depicting here is a traditional wireless access gateway-based model where we take and physically tap links all around the key components that make up a wireless services activation: DNS servers, DHCP, AAA, any captive portals, any roaming partner connections. So this is traditionally what we do. And then we feed that into the probe there. A little Netscout probe is where all the kind of secret sauce, smart data magic happens. And what that has allowed them to do, and I kind of look at Wi-Fi as a 4-phased approach. In the first phase, they just wanted some smart data to allow them to see which of all these pieces might be having the problem. I would call that phase 1. So in this case, you're looking at a dashboard of a specific region of one of our MSOs. They've developed a key set of metrics that they initially relied upon very heavily. At the top layer, you get physical layer characteristics, things like bit rates and packet loss, or packet rates, things like that. But then they also wanted to take a look in one single pane of glass. They wanted to see how each of those components is performing. So at the second tier, you have transactions, green for good, red for bad. They wanted to know that those transactions were completing quickly, so they wanted response times. And then if any errors occurred, in this case we probably only see it here for DNS, they wanted to outline that. So for every region, in most of the MSOs that I deal with, they have a set of these dashboards for a region. Some like to have a rolled up view, of the entire network. And this has allowed them to be very effective with troubleshooting and seeing problems when things start to degrade. Now, phase 2 of this, of smart data for Wi-Fi, our MSOs came to us and said, okay, I like that I can look at systems and identify systemic issues. Now I want to see how long it's taking a device to actually get an IP address, because that's a user experience metric. How long does it take DHCP to complete? And when that completes, how long does it take before I get my first bit of data from the network? So these are new metrics, kind of phase 2 smart data metrics that we developed for them. So they've got dashboards across their different regions, across their different network that show them that as well. The third phase, I would say, in Wi-Fi would take these metrics that they agree upon as their golden metrics and be able to dimension based on individual access points. So one of the unique things that we do, by virtue of being instrumented, one more slide back, by virtue of being instrumented across the WAG there, we're able to pick up from the wire active access points and apply smart data towards those access points as well. So it's not just looking at AAA and DHCP, it's now being able to tell you, in this case, how DHCP is performing for every single access point in the network, and in some cases we're talking about millions of them. So they can begin to focus that lens, right? At the dashboard level, you have a wide lens, you see there's a problem, you begin to focus it down. In this case, they wanted to focus it down to the AP level itself. So it's very nice in this case. So that applies to DNS, that applies for Captive Portal. You could say how is web performing across a given set of APs within the a given market. So what you see here, this is just simply a drill down from the dashboard where they can see the error codes that are associated with a single AP or a group of APs. And last but not least, they said this is great. Now I can dimension all of these metrics by access points, by systems themselves. Wouldn't it be nice if we could then start to dimension data based on individual subscribers, based on devices? So what you're seeing here is not a Netscout visualization. What you're seeing here is a third-party visualization using the data from the wire, the smart data that we provide to the system, to show you, and I've had to black out some of the addresses there, but on an individual MAC-by-MAC basis, if you did have that subscriber that called and said, I had a bad quality issue yesterday at 2 p.m., you would have the ability to put in their MAC address, look at all their throughput, average throughputs, how much did they download, also take a look at what happened when they went to Amazon or when they went to Facebook. So you've gone from very wide lens looking at systems to looking at APs to now looking at single subscribers. So this is a very good illustration of the power of smart data and how you can apply that. Again, this is a third-party tool. We don't care about who we send this data to, but you can take it and do what you like with it. So, okay, let's talk about video for a few minutes. Video is a challenge, right? There's a lot of churn. People were cutting cords. Just a lot going on with video. I think people in the audience are probably not all that familiar with Netscout as a video monitoring company, but we actually are. We're doing some unique things in the MSO space around that. But if you look at the challenges that our, Netscout, our customers, our MSOs face, we picked the top 6, right? I can't get my guide, or maybe my guide is slow as I turn the channel. I can't even get into my over-the-top app. When I get in, maybe the streams don't initialize. When they do initialize, maybe they end before the asset is done playing out. Why can't I get to my bookmarks and the age-old choppy video? So what we've done Netscout-wise is we've helped take the complexity of managing video at the control plane, because really if you look at some of these networks, they're massive, complex webs of interdependent applications. Some of these applications live locally on bare metal, some live in a private cloud locally, some live in the public cloud. They're all over the place, and they're very hard to troubleshoot. It's very hard to isolate where the problems are. In many cases, the components that make up an MSO-based video solution use proprietary control plane protocols. So we've gone into places where people are literally trying to build Wireshark decoders to understand proprietary signaling techniques. We take the complexity out of that by developing smart data plugins. And really at the end of the day, at least in many of the networks that I deal with today, it's all about providing enough smart data to allow people to say it's either the network or the application or it's both. We see this all the time, right? That's not going to go away. But the idea is to give you enough data to prove that maybe it is a system or is not the system that you're owning today. So same sort of thing with video as Wi-Fi. In this case, we're looking at a video solution where you've got back office components, pumps, session managers, which are the device that's upstream from the set-top box itself. So tapping and aggregating all those points so that you can see all the traffic flowing amongst those types of systems, and then beginning to develop data against each of those points. So in this case, I'll show you video. This looks familiar, I'm sure, if you were watching the Wi-Fi slide. This is their visual representation of a hop-by-hop analysis. Right on the left-hand side, you have set-top box communications to an upstream element. You might be doing some stitching, some caching, some pump, some back office. This is a very nice way for them to have one place to look, even though they've got a couple other panes of glass and other tools. One place to look to determine if something is broken or something goes bump. I can visually see it here. There's alarming that happens behind the scenes as well. But we make it very granular. So if, for instance, an MSO wanted to go as far as saying, I want to know when someone pushes play or pause, how long does the system take to actually acknowledge that play or pause operation, and did it occur? You can do those things. This is a very high-level sort of dashboard, but same sort of key, I keep calling them golden KPIs. Transactions, did they succeed, did they fail? If they failed, what kind of error codes? How long did they take to respond? And in this case, they like peak sessions as well. That's an indicator in some areas also. So the idea here is to not just have another dashboard. Everyone has a dashboard, but in this case, they really like the ability to visualize that, and they can get bigger or smaller, get custom things as well. So in this case, if I happen to see, and I was an operator, happen to see a problem at the set-top box layer, this was actually an event that happened a couple years ago where it was a complete guide outage. So you see right where it goes red, something on the dashboard went red, began to degrade. Behind the scenes, we apply some machine learning to say this is abnormal. You should go look at it. But they can visualize this and know that immediately it's between the set-top boxes and the upstream element, and then give them the ability to drill down into those. And this is just the second drill down screen where we start to really give you the smart data to dimension on. In this case, we see that it was a session setup from the set-top box to the upstream element, and 100% of those were failing. So, they had some, in this particular case, they had some log-based tools, but at the end of the day, this allowed them to find the problem and fix it a lot faster than if they were waiting on their existing alarming systems or if they were trying to scrape logs to get there. And last but not least, data center transformation. So data centers are transforming in wild ways. Applications are being virtualized, applications are living in containers, applications are living in VMs, applications live locally in private clouds, applications live in public cloud. In the data center implementations that we're involved in, there's one constant, and that is the need to stitch together metrics across the service chain. East-west, north-south, be able to get those same metrics that you just saw in Wi-Fi and video, but do it in a data center. And that is fairly challenging. And when you want to do that, another key consideration that we're asked is, well, I don't want to impact the application performance itself. I don't want to have to use packet mirroring on a vSwitch and make that work when I know that it really is not a passive-based thing to do. So in our case, we decided early on that there were better mechanisms to interface with VMware or with OpenStack from an API level versus just doing packet mirroring itself. And we'd be happy to talk to you a little more about that in the booth, should you like it. So really, here's a picture of a hybrid data center. On the right, we have the data center itself. I would say best practice in the networks that I've been involved in would be to tap and aggregate, physically tap and aggregate the points at which you care about. And that's typically firewalls, load balancers. Maybe you have a set of compute links or a set of servers that are handling functions that you care about. So and the ones I've been involved in is get visibility at those points first and then roll those up to the ingenious one single pane of glass on the right there. But that doesn't handle everything. How do you know if you have physical tap points what the performance looks like within the private cloud if these applications are going east to west? So Vikram talked about visibility without borders. We're not bound by any sort of border in the private cloud case. You just simply put a virtualized version of the probe in that environment. We're not bound by physical probes in the case of the public cloud. We have agents that can run there as well, where you can get access to packets just as if you were physically tapped there also. So, we like to see ourselves as borderless. We like to see ourselves as able to accommodate all the different visibility points in the next generation data center. And we are actively doing this today in the networks that we're in. So we'd be happy to talk to you more about it today or during the show. If you want to stop by the booth, it's right there. And I figured we'd leave the last 5 minutes or so for questions.
There's somebody's slide.
Oop. Oh, I'm sorry. So we've done this before. We are with the operators. We see them embracing digital transformation. We've been around 30 years. We've done this in the largest networks, the smallest networks. But really for us, it's about taking that smart data and applying it to what you need to get you the visibility levels you need. And feel comfortable that when you transform, if you will, when you move to a new digital world, that you'll have the same visibility that you would expect.
Any questions? Anybody has? Happy to take any questions now, or we have a booth, like we said, we can show you more stuff.
I have a question. Is your technology specific to any vendor?
Yeah, good question. No. So as Ryan showed the pictures, we don't take data from any element a network element. We are actually tapping either the physical wires or virtual wires in data center. So we look at traffic across the network, which is completely vendor independent.
Yeah, all we care about is getting a packet stream from the places that you need it from.
So it's a good way to monitor all your vendors without actually looking at their data. So to keep them honest, like in Wi-Fi, we can qualify the access points, we can qualify DNS servers without actually depending on their data. So.
And that's a good point. I would say that many of these companies we deal with, they have logging-based systems, they have the Splunks of the world, but they use us as the source of truth because the wire doesn't lie, right? The packets themselves don't lie. So it's a nice way to help them validate that.
Yeah, here.
Not sure if I missed it, but is over-the-top streaming and monitoring part of what you showed or on your roadmap as well?
So you're talking about ABR-based over-the-top video?
Yes.
We definitely do some things with that. We do some things in the area of scoring, say, encrypted over-the-top video. So we'd be happy to talk to you about that as well. So that is a part of our portfolio. Mm-hmm. In this case, in the case of over-the-top, what we're doing in some of these places, there's a whole back-end infrastructure, control plane infrastructure that we help monitor there as well. But if you're talking specifically about video quality itself of ABR, we do have some solutions. But yeah.
Okay. All right, thank you very much.
Thank you, guys. Thank you very much. Great presentation. We're going to regather in about 10 minutes for a presentation from Intel. And I hope you'll stick around and bring your friends back for that at 3 o'clock.